Hi, I'm Andrew with AGL Mechanical Tips, and in this video I'm going to show you how to attach a takeoff to a trunk line properly. There's two tools we can use to cut takeoffs into trunk lines. For years and years and years I used a pair of just red snips. And every time I went into the supply house I saw this tool and I said, man, that thing probably doesn't work all that great. Then one guy working with me had it and I used it and I loved it and I've been using it ever since. But it's still good to use both methods because you will be on a job site one day where you break a bit, you don't have a replacement bit, and you're gonna have to use a pair of snips. I'm gonna start by showing you how to use this hole cutter here. And I've got a return can here that we're gonna put a takeoff on. I wanna bring up that this takeoff has a very wide flange on it. So when you set this hole cutter here, I actually set it a little bit over 10. Like I want a 10-inch takeoff. I'm actually gonna set this at like 10 1/8 or 10 1/4 to give me some wiggle room so that when I apply this takeoff to this return can, there's no metal showing in my hole, because if there's metal showing, it's gonna affect your airflow. A small sliver is not gonna really do it much, but if you can avoid it, why have it there? So in this case, I'm setting mine to like 10 1/8. That gives me a little bit of wiggle room. And simply start with my starting point. So I got a return can here and this takeoff's gonna go dead center. If I had a weird application, I might wanna offset this takeoff on this return can. This is kind of too big for this application, but just keep in mind that when you're cutting your hole, you can always offset it on these boxes. Don't always have to cut it dead center. So I'm gonna start in my middle here. And what I like to do is, I normally don't mark my center because it just doesn't matter that much, but I'll place it, I'll eyeball it center, and I'll draw that circle out real quick and just look at it and say, yeah, that makes sense. And I'm gonna go ahead and drill my center point here. Once you have your center point in, you just simply insert this here, drill down. One thing I want to bring up is the angle right here does affect the efficiency of this cutting. If I hold it straight up and down, it cuts it very slow. But if I hold it at a slight angle, it hits that bit in a better area and it just cuts much, much faster. So when I get to this point in my cut, there's now, when I continue, there's gonna be no material to stop this centerpiece from shifting out. So you wanna start holding this here and keeping tension on the material that's remaining. So when I actually get to this point, I'm gonna be pulling towards me to keep this metal tight. You'll see what I'm saying here in a second. So I'm now pulling this way. Because I pulled this way, it enabled me to finish my cut without having to pull out a pair of snips. Couple things to bring up here. I put this piece of metal here because we've got all these metal shavings that came out, and I'm just gonna simply roll a trash can over here and dump these metal shavings into it. If you're on a job site, you don't wanna do this in somebody's house. You wanna do it over a trash can or just find an area where this is acceptable. A couple of quick things to note about this tool. It's important you keep this bit sharp because it does affect safety. When you're pulling back and putting tension here, you don't overdo it, and also just be aware, this is kind of common sense, but this is sharp metal. And if you're pulling back this way and you slip, you can get your hand in here and cause an injury. Also, when you're tightening down this arbor here, it's very easy to break this arbor. So I recommend getting a short crescent wrench. That way you don't over tighten it when you're setting it. I've snapped a bunch of them. It's easier than you might think. So just be aware of that. And then also with the bit, when you're drilling it, don't put too much tension on it because you will break the bit. Cutting the takeoff is actually quite simple, but I want to bring up assembly line process and the huge time savings that you can have as it relates to takeoffs. Normally this is closer to the end of the project when I start cutting these things. Normally I have my trunk line suspended up in the air. I've got all my runs in place if I'm doing an attic job, and I install these assembly line process just like I would everything else. I'd normally go around and figure out exactly where all my takeoffs are going. I would mark them and razor knife them. So I'd be running around with a takeoff and a razor knife, and I'd be marking all my takeoffs on my trunk line. Then I would come back with my hole cutter, set to one specific size, and I would cut all of that size takeoff. And then I would go and adjust my hole cutter to do the next size, and I'd go around and cut that. Now that's in a perfect world. It's not always gonna work like that. But I just keep in mind assembly line process with this, because the time savings is huge. You know, you're not carrying a drill with a hole cutter and a razor knife and a roll of duct tape around an attic with you. You're just simply carrying around one thing, you know, this and this. And then when I'm at this part, I'm gonna roll around the attic with this. It should be a very quick process. Another thing I want to mention, if you're doing a crawl space job, or any kind of job that there's a opportunity to get your material in a workable space that is, you know, you're not laying on the ground trying to cut a takeoff sideways. There's been a lot of projects, crawl space jobs that, you know, it's a 2-ton system, it's a short trunk line. Trunk line might be 20 feet long. And I had the opportunity to actually slide the whole trunk line in one piece, mark all of my takeoffs on that trunk line, and then slide that whole trunk line back outside, cut all my takeoffs and slide it back in. You need to really know what you're doing when you're doing something like this, because if you get it wrong, you have 12 holes that are cut wrong. But if you're confident in what you're doing, you've done it enough to where you know it's right, you're gonna save a huge amount of time by doing that. Another thing I wanted to go over was when you're in a crawl space job and you're cutting takeoffs, you don't wanna cut it right on the side of the duct, because this duct is now gonna be, you know, 8 inches from your joist. And in a crawl space, especially a tight one, you want your runs up as high as possible to allow people to work in that crawl space later. You know, you got plumbers, got to work on a plumbing leak. He's got to crawl under every single one of your runs. So if you're cutting your runs perfectly level, there's a lot of height missing. So you could offset this takeoff just a little bit up like this, you know, and have, or, you know, if you're doing hard pipe, you can have your hard pipe angle out towards where the run goes. I normally don't go up like this and add an elbow, because you're now affecting airflow. But just be conscious that the height in the crawl space is affected by this. Another big thing, and this is also huge, you need to cut the takeoffs where the plans show them as it relates to your reductions. So if I've got a 16-inch pipe, there's a certain amount of takeoffs that need to come off of that specific size pipe before it reduces down to 14. So when you lay out your trunk line, you need to be keeping an eye on where your reducer lands. And after you hang your trunk line, you might have one run that actually lands on your reducer. It needs to come off one side or the other. You need to go and resort to your plans and find out if it can come off the right size. If it can't, you need to talk to whoever's designing the duct system. If it's you, then you can make the determination if it's going to have the right CFM. If not, you have to go talk to the designer, see if you could shift it over. Another thing I need to go over is we've got an end cap here, and I normally try not to I don't come off the end of a trunk line with a run unless there's a significant issue and there's no other way of doing it. But it's good practice and needs to happen that you stay a foot from your end cap, if not more. This trunk line is actually like a pressurized system. So if you're right at the end, you're gonna get much more airflow out right here than you would right here. Another thing, when you're putting takeoffs onto a trunk line, it is a terrible idea to put 2 takeoffs side by side like that for a number of reasons. One, it's gonna be extremely difficult to tape around this. You know, when you get you're gonna be fighting both takeoffs on. You've got insulation from 2 ducts now here that you need to seal around. Then you've got to mastic it. It's gonna look terrible. So try to keep them apart. About that far is probably good. You know, we try to keep our takeoffs as spread apart from each other as possible. It does affect airflow to some degree if you're coming right off of both sides of this trunk line here. We try to avoid this. We will try to stagger these takeoffs and not come off the same section right across from each other. One thing you definitely don't want to do is take a takeoff off of an elbow. Don't do it. It'll cause all kinds of problems. Also, we try to stay away from elbows when we're cutting takeoffs, at least a little bit to end the turbulent flow that's going through here. You know, so I'll try to install a takeoff, you know, like that far away from an elbow. You can probably tighten it up a little bit, but just be conscious of it. Try to stay away from it. Lastly, you need to stay off of square duct transitions. So if you've got, you know, 22 by 10 duct that reduces down to 16 by 10, don't put your takeoff on the reduction itself. I showed you how to cut a takeoff using a hole cutter right here, but in some weird scenario, you know, towards the end of the day, you break a bit or you don't have this tool or your drill battery's dead or something like that. you can also use a pair of snips. I'm going to show you how to do that, but I'm also going to show you how to cut into fiberglass duct the way that we use here. So the first step is determining where your takeoff goes. And as I discussed earlier, you should already have them all marked out on your entire trunk line, if possible, before you even start this process of cutting. But for the purpose of this video, I'm going to go ahead and draw one and cut it out. So here's my first takeoff here. I'm looking at my angle here. I'm staying away from my end cap. I'm not at the end of an elbow, so this is a good spot for my takeoff. I'm going to take a marker. I'm going to mark out that circle. If for any reason you dropped your Sharpie on a new construction job or something, don't run all the way downstairs to grab it. Just simply go like that if you're only doing one hole. But again, if you're using an assembly line process, and you should be, use a marker, you'll have it all marked out already. I'm then going to take my razor knife and I'm going to cut out my marks from earlier. We remove our material here. And I'm going to cut 4 slits. I like to do it at the corners like this. And I'm going to take that and I'm going to tuck it under itself. Now if I'm using a hole cutter, I'm actually going to come over here. I can see the scratches on the duct from my razor knife. I'm going to hold my hole cutter here, find my center. I'll actually swing this around sometimes in certain situations to make sure it's perfectly centered. Then I'll cut it. But we're using a pair of snips here, so I'm going to grab my takeoff again, put it right back on there. I'm going to look inside and make sure I'm lined up with my scratch marks here, and I am. And I'm going to draw a circle. So this is what I'm going to be cutting out. Like I explained with the hole cutter, I set the hole slightly bigger. So this is a 6-inch hole. If I was using a hole cutter, I'd probably set that hole cutter to 6 1/8, 6 1/4, just to give me some wiggle room. So if I go to stick this takeoff on and I didn't stick it perfectly, there's no metal coming into this takeoff here, which would affect the airflow of the duct. It's almost like adding a damper and dampering it down. Even though it's a small degree, it's still wrong. Just make sure there's no material shown. So I've got this here. Now there's a couple of methods to starting your hole. I've got a method that I like. There's a ton of people that don't like my method. Find a method that you like and use that method. But you can use a drill with a drill bit. I think that that's too cumbersome because you're now having to carry a drill with the drill bit into the attic or the crawl space that you're at to do this process. The most popular one I see is a hammer with a flathead, where they put the flathead up against the duct and they hit the flathead with the hammer. I don't like this method because I see it putting a lot of stress on the straps when they're doing it. And I've always been nervous watching somebody do it. It works, there's nothing wrong with it. Just know that. The method I personally like, and it does seem unorthodox, I actually pierce the duct with my snips, and it takes a while to get good at this. It might be difficult for me to do up top on this table, but I'm going to give it a shot. The first thing I do is I actually put in a dent into this duct like that. What that does is this stops, when I'm going to pop it with my snips, it stops the duct from bouncing. So it allows me to pierce a hole here. So I'm going to step in the way of the camera here. I'm going to try to keep out of the shot. And I'm going to try to nail this dead center and put a little hole in it. So there's a hole right there. This is going to allow me to get my snips in here and start cutting my hole. I personally like offset snips here. At a slight angle, they make them deeper, but this is good. It keeps my hand out of the way. They have straight red snips, but your hand keeps down a little bit. Just want to let you know that there's different kinds here, and it does make a pretty big difference on the comfort. But now that I have my slit here, I'm going to start by getting my tips in here. And I'm going to continue doing a spiral outward, because if I cut straight to that line, the blades actually get hung up on each other. It gets hung up on the material that's the waste material. It's hard to explain, but if you do a spiral, you're leaving room for this blade to get into the duct fitting. So there's a reason that I'm making it ugly like this, but see how fast I'm able to move, and I'm able to move with no resistance. So now I'm going to cut slightly past my Sharpie mark because, like I said earlier with a hole cutter, I set it slightly bigger. So I'm going to take my takeoff now. I'm going to line it up. I'm going to look inside. I'm going to make sure that there's no material showing. And then if this is good, I'm going to go ahead and peel this gasket off. If you notice on my duct here, that dent I put in previously is completely gone. So that's why I like this method. It was very quick, very fast. Didn't mess up the duct at all. I put this takeoff on here. And I'm being careful to look at my radius here. If this takeoff didn't fit perfectly when I dry fit it just a second ago, sometimes I'd warp out the takeoff. Like let's say it was going on bigger duct and I have this radius here and I'm doing 16-inch duct or something. Sometimes I'll come and bend this out a little bit and then put it on the duct and see how it feels. You know, sometimes I'm actually going in. Normally I'm going out. Now that that's there, we're going to screw that off. And you don't have to use the screw holes that came in the takeoff. You can put them anywhere you want. Really, if you see a gap, you should just go ahead and screw it there. So that actually contoured pretty well, and it's a pretty good seal. If this was in non-conditioned space though, we would still go ahead and mastic tape over this. We'd mastic tape over where this connection seam is. We'd mastic tape over this hole. We'd have it completely sealed. Today's construction, we're normally in a spray foamed attic. That spray foamed attic is technically part of the conditioned envelope, and any leakage into that attic is actually leaking into conditioned space. So in that case, I would call this good to go. I'd go ahead and peel my insulation back over it. And I'd tape this up. Now, I recommend not using a single piece of duct tape here. And it's because in a hot attic, if this takeoff sits for a little while, and it might because you've cut all your takeoffs at once. So this takeoff is going to sit in the attic for a while with just one strip of duct tape on it. The attic gets warm, that duct tape will slip and it will pop loose. I've seen it happen a ton of times. So I use doubles here. Stick it to one side. I'm not pulling tight. I'm lining up the vapor barrier with where I originally cut it, and I'm folding it down. I didn't do any tension there. I just put it together. And I'm going to do that to all four corners. And this is how you cut a takeoff into insulated round duct. Now I'm going to show you how to make a connection to this. There is a wrong way to do it. So now I'm going to make a flex duct connection here, and my method of connecting this might differ from some people. This is the way I use, this is the way I like. I think it works great. The requirements were probably written back in the 1970s or 1980s. You know, this actually says copyright 2010 Air Duct Council, so I'm completely wrong on those dates. But it even shows them using a pair of bulldogs to cut the wire inside the center core of the flex duct. If you do that, you're going to ruin your bulldog. So I laugh at that. I don't use that method exactly. What I like to do is I duct tape my connection. I don't use these zip ties on the flex duct connection. I've done enough tear outs in attics where I've learned that just using these, I can simply go up to a run and pull it right off the trunk line. So the method I use is just simply duct tape. If I'm in a crawl space or if I'm in a high ceiling application, I may add this to insulation to stop the insulation from backing off of the boot. But 99% of the time, I'm just simply going to use duct tape. I'll show you my method. It will make sense when I'm done. The first thing you do is you open up a bag or a box, and you could pull all of this flex out. I found it easiest to just flip this upside down, pull up like that. There's your flex. First thing we always do is we then grab it by its core. We tuck this vapor barrier into this flex on both ends. This is always the first thing that we do, and sometimes you'll find defects where that core is further down the flex and has to be fixed up. The next thing we do is holding the core of the flex. We're gonna stretch this out to make sure it's not bunched up inside. This takes two people. Hey, Sven, come here. So he's holding the core, and we're just gonna stretch that out real quick, and I'll pull on the jacket a little bit too. All right, I'm gonna tuck my ends again. The reason I'm tucking my ends is I don't want this fiberglass to fall down into the vapor barrier, so we always keep it tucked when we're working with it. If we cut it, we tuck it. If we move it and it comes out like this, we tuck it. I know you guys are probably like, God, he's gonna talk about assembly line process again, and I am, because it's that important, but when I'm laying out a job, we're not putting up one run at a time and then cutting our flex. So in an effort to reduce waste, we're gonna try to utilize as much of this flex without splices as possible. So the first thing I do when I get on the job, or when I'm at this process, is I'm gonna start trying to figure out the total length of my runs, and if I can achieve that run with a half of a box of flex or a third box of flex, or do I need a full box of flex on it? So if it's a really, the run's really close to trunk line, you want some flex for noise reduction. So if we have a bathroom that comes right off the trunk line, I actually don't run that flex right to that bathroom vent. I actually do an S-turn on it to avoid noise coming from the trunk line or excessive airflow. So each run should have at least 4 foot, 6 foot of flex on it. I also recommend each run having two 90s on it, one at the boot and one near the takeoff if it's that short. But also, so if I come to my job and figure out that I can do that job with a half box of flex, I can do 3 runs with a half box of flex. What I would go ahead and do is open up 3 boxes of flex. I dump them on the floor. The method of figuring out the halfway mark is here's a quick trick, is to line these 2 flex ducts up here, come to my end over here. This is my halfway point. I'm gonna cut it right here. So on a project that I can get away with really short runs, I'm gonna do an S turn on this. And I'm gonna cut right there, and I'm gonna cut right there. Now I have 3 boxes, or 3 runs, a third of a box. So keep in mind when you do this, that you're gonna lose a little bit to your attachment. So this ends up being a slightly shorter, and it's rare situations where you can get away with a third of a box of flex. But you always wanna be longer, not shorter. Splices make the quality of the job go down. We try to avoid them at all costs. When you're installing boots, I always recommend that your flex already be attached to this boot before it goes up in the ceiling. If you're using a magic boot, even if you're hanging that magic boot the same day, you can mastic that. And if you go to hang that boot by holding it in the center and put it up, you're not gonna get mastic all over you. If you're using a boot like this, you need to solid mastic this. You do need to plan out your job to have dry time for that. So in that case, if you're planning on hanging a straight boot the same day as you're prepping the fitting, then you probably don't want to mastic it. The reason I don't hang this boot in the ceiling and then make a connection is pretty obvious. One, it's really easy to do right here. And 2, if this is in the ceiling hung, I now have to make a connection while this is making a turn. And it's difficult for this material to look good and connect right and your tape seam be nice and straight when it's on a turn. So the best method to do it, and I see people, let me show you the wrong way of doing it, is to set this boot right here, grab your flex, and try to hook it up right here. You can totally do it. It's just gonna be a little bit more difficult. The easier method is to take this boot, get your duct tape ready, put this right here. I'm using my leg here and my leg here. Put my flex right here, and I'm now lining right up into this right here. I can get to 100% of my connection right here. I'm putting my tape seam around. And I'm gonna be sure to rub this in really good. I just want to demonstrate really quick how well this one piece of duct tape is going to do here for a connection. And if you install this flex duct properly and you strap it properly, there's never going to be tension on this flex duct again unless somebody for some reason kicks it in the attic. So I'm gonna have Sven over here pull on this flex just to show how strong this connection is. Sven, if you go ahead and grab that for me, please. I'm gonna back up from this. It's not moving anywhere. If we were using this Panduit strap with a Panduit gun, this connection would have pulled off the first time he pulled this flex. And that's why I believe this method is fine. It outlines using duct tape and a zip tie. I think it's a lot to carry around. I don't think it's necessary. I don't do it. The next part is, you see me constantly tucking this. I'm constantly making sure that this fiberglass is protected from pulling down into that vapor barrier. That's the one defect with flex. It's not really a defect, just you have to take special care for it not to happen. So I've got my inner connection already done. I'm gonna pull this on a straight boot. I pull it as far up as I can. I do not torque down on this insulation on a straight boot. I'll show you what I mean about torquing down when I do it to a takeoff. But for a straight boot, I just simply get that nice and snug over there. And I tend to like to use doubles here, so I'm gonna check this side, make sure it's good. Everything lined up. Big doubles on this one. I hold my duct tape like this, and I press it over that straight boot, and then I rub it in. Flip the fitting over, do it again. I've already made it all the way around, but I'm gonna go ahead and add another piece of tape just to be sure that this doesn't come back up. Now, as you can see, this is an extremely clean looking connection here. It was much easier than trying to connect that while it's in that position. If this is going in tomorrow or the next day, if there's enough dry time for my mastic, I recommend solid masticing this, whitewashing it from right here all the way down to about 2 inches past this. It'll look clean, it'll look perfect. So here I've simulated the conditions that should exist before you start cutting your runs to length. So I've got my run strapped properly with proper spacing. There's no loose spots in my strapping. My flex is not zigzagging like this. It's important to make sure all of that is right before you cut your trunk line, or before you cut your flex duct here at your trunk line. So my boot side's done. We already went over that. It's already in the ceiling, it's attached, it's installed, and we're strapped all the way back now. And I've actually, to keep with the assembly line process again, let's say that all the runs in the house are at this point. So we're at this point now, and I've got a pair of scissors in my hand, I've got a pair of Dykes in my hand, or in my pocket, and I've got a roll of duct tape so that I can go and do all these takeoffs at one time. So first thing we need to do is determine the length that we want to cut this flex. It's important you take your time here, because if you get it wrong, you have to add a splice, you have to add insulation. It just adds more time and it doesn't look as good. So you don't want to measure and cut this right at this mark. You want to allow a little bit more insulation so that when I do this tuck that I keep bringing up, you have the insulation to do it. So I'm actually going to come back about 6 inches from where this is going to connect, and I'm going to cut the flex right there. I like to use a pair of scissors to do this. You can use a duct knife is good. Scissors tend to work real good, tend to give me a real clean cut. And then we have this core here. We're going to use our pair of Dykes to cut this. Now this is a great opportunity to show you an AGL Mechanical Tips exclusive tip. If you're in an attic, whoops, I dropped my Dykes. I've got this one run left that I need to cut. But I do have my scissors with me. But I don't have a razor knife, and I still have to go through this core. I'm going to pierce this right here. Pull this wire out like this. Take this wire, loop it together. Keep it very tight right here. And start pulling that tight while keeping this together real tight. And we've just cut that wire, saved us a trip from having to run downstairs to grab our dikes. Our flex duct is now cut to length. And again, I'm gonna come over here. I'm gonna tuck this insulation into itself like this. I would do this before I start making this connection. And you can see now that my core is a little bit longer now. I can cut this off, or when I set this onto my takeoff, I can bunch it together and tape over it. You don't want a very loose core in here if you can help it. Normally it's acceptable to have a little bit of looseness in that core. So I'm gonna go ahead and tape this seam here. I've got my seam taped here. You can see really strong connection even just with one piece of tape. So I'm gonna stop right here and I'm gonna show you the wrong way of doing this before I show you the right way, because the wrong way is what I see more often. So there's two ways I normally see this done. Somebody just starts taping right here. As you can see, there's a lot of play here. So when you tape it, it just kind of, it's not a rigid surface to tape to. Another thing I see is they'll just start going around it like this, as tight as they possibly can. And then you're left with this that's popped up. And it's taped over like this. So this is what I'll typically see. And when they go all the way around, there's a little hole here that like Mastic can get in, and it makes it difficult to mastic. I don't like this method. You've compressed the insulation so much that you've lost R value here. Your connection's gonna look like garbage, and when you go to mastic, it's gonna get all up under here. It's gonna be 3 times harder to mastic.
Very good. You know something? No soup for you!
All right, so I took that garbage off and I retucked my flex. When I tucked my flex, I doubled it up. I rolled the fiberglass into itself with the vapor barrier over it, and there's now actually like 2 layers of fiberglass wrap under here. See, this flex is actually way looser than the fiberglass in order for it to make turns and still retain its R value and all. So what I'm gonna do at this stage is I'm gonna tighten this up just a little bit with a double piece of duct tape. And yes, it is true that when you compress insulation, you do affect the R value of it, but I'm not going to a crazy degree, and I've also doubled this up. So I'm left with now a clean, rigid surface here to tape to. And when I tape this up, I again am gonna use doubles about 5 inches long. And this is where making it look good really come into play. What I do is I kind of hold this tape like this and I'm folding it. And I'm gonna tape just on the flex duct first. And I'm actually come in here and I'm gonna start over here, and I'm actually pushing down while I'm like pushing down, but then pulling that material outward, and I'm contouring this duct tape around that radius like that. So it just fits. More on Panduit straps. I don't use them, and I agree that if it was an upgrade to add the Panduit, even if it's not doing anything, why not just put it on there? The problem is I think it is actually a downgrade, because I've seen on the field many times a duct system in non-conditioned space where the whole duct system's doing completely fine. I come up to where this Panduit strap has been over torqued onto here, and that strap is sweating. The duct's sweating right at this section because it is so tight that the R value has been affected. There's only one application where I feel that these should be used. It's when you have a heavy duct like 16-inch flex or 14-inch flex or something, and it is dropping down a wall vertically. It is hard to take the weight off of that flex. And if you don't take the weight off that flex, what ends up happening, the fiberglass that is against this vapor barrier, there's nothing holding it but the tension of the vapor barrier. So if there's a lot of weight on this, eventually that fiberglass is gonna come separated, and you'll walk up to this duct, it'll look perfectly insulated, but you'll touch right here and there's no insulation there. So now that I'm bringing up that point, if you're putting this duct into a crawl space and you're not putting Panduit straps on that, you need to immediately strap this duct up. So you put your boot in and you strap it to where there's no tension on this. You know, if you're gonna come work on this the next week or next day, chances are if it's hanging with all this weight on it overnight, you know, in a garage application, like you got a high ceiling here, the boot's hanging here, that flex is coming down, that insulation will fall down. So it's important that you do strap this right when you put it up. This is our completed connection to our takeoff. This still needs mastic, but I'm on my layout table here at my office. I have to disconnect this. So I'm not gonna mastic it, but I'm gonna show you that when you go to mastic it, don't just mastic around your duct tape here. Make you a nice, clean, rounded or mastic seam that goes all the way around. You know, just make that one solid piece. Solid mastic this all the way around to here. That way, when it's done, it's gonna look like this fitting's growing out of this duct in its factory. Now that I've taught you how to make a round takeoff connection in your bitch, it's time that you make the subscribe button in your bitch by clicking on it right now. I'm Andrew with AGL Mechanical Tips, and remember, quality is your reputation.